instead of being copper iodide or copper bromide or whatever that is, copper 1, yes? What you are going to get is OH. You treat it with hypophosphorus acid, and what you are going to get is H.
I like these ones.
This stuff here about azo dyes, you read it. I'm not going to put it on the test, okay?
Which one? Which part?
Azo dyes on the bottom.
Okay, but for real, so the N2 gas leaves, and what happens with the copper? What does it leave with? Or what does it do?
You mean you want to know what the copper is?
Yeah, it just disappears.
The copper does not disappear, the copper is still there.
I know, but why? By itself?
No, it's not by itself, it's probably bonded to something that is negatively charged. Could be to water, could be to, I don't know, other things. I don't know if I should continue doing these problems here. Okay, maybe we should do a little bit of IR. What do you think?
Yes.
So, here on out, the rest of this stuff is going to be on the final, right?
The rest of this stuff is not going to be on this test. This is going to be on the next test.
So after this thing,
Whatever we didn't cover on the paper, it's not gonna be
Whatever you do on the board, that's what will be.
Whatever I did today on the board is what's going to be on the test. But that doesn't mean you should not read the paper and know about it. Okay? I'm not going to put it on the test. IR. We have to cover IR, NMR, and mass spec on Tuesday of next week. Whatever we don't do today. And I'm guessing today we're not going to do a lot. Okay, so you write this down. I'm not going to write it on the board. IR is a vibrational technique. Okay? So IR would do what to the molecule? It will make it vibrate. Okay? When you took 1046, I said when an organic compound is irradiated with a specific IR frequency, and that frequency matches a vibrational frequency in your molecule, that radiation is absorbed by the body. And this absorption is called the resonance. And this leads to different modes of vibration. This leads to stretching, bending, and translating. Okay? I'm not going to ask you that on the test, but that's what it is. So, when you have an IR signal, the IR looks like this, yes? The IR comes down from the top. There are peaks in places, yes? Left-hand side is 4,000. Right-hand side is about 660, whatever, doesn't matter, 557. And the bonds that are on the left-hand side are stronger bonds than the ones on the right-hand side. So if you were to have this, and I am not going to ask you to memorize these numbers, okay? So I'm not even going to give them to you. I did give them in 1046, but not here. I'm gonna give you a paper with all the numbers next class. Where do you expect this absorption to be at on the IR? On the left-hand side, right-hand side, in comparison to this? Okay, this will be here, then comes that one, and then comes this one. So the weaker absorptions are to this side. Okay, but stronger and weaker is also about the size of the peak. Yes? The lower they are, the stronger the absorption. Now, I can't say, oh, 56 is what makes something strong. Okay? So let's say this is 100%, and let's say that this is 0. It's never 0. 0%. This absorption of a peak that goes almost all the way down, is that strong or weak?
Strong.
That is strong. This is a strong peak, a strong absorption. If the peak is like this, that is a weak absorption. That doesn't tell you about bond strength. Okay, bond strength is where it is placed in the IR. Yes? Now, some of these numbers in the IR, they overlap. What I care about is, we do this the short way. Here's 3,000 in the IR. If you see a big ball like that in the IR, that is smooth on the bottom and broad, most of the time this will be an OH. That will be an alcohol. The place where this is going to be at depends on the amount of hydrogen bonds you have. This would be around 34, 3,500. If it had no hydrogen bonds, if it did not make any hydrogen bonds, it would look like this, sharp and narrow. Now, if it has hydrogen bonds, then it will never look like this. I've never seen one that looks like this. Because if you have a substance, and there is more of them, they will make hydrogen bonds, yes? So, but the more hydrogen bonds that it makes, the more it takes that broad, what is this called? Peak to the right-hand side. So if it makes hydrogen bonds, instead of 34, maybe you expect it lower. Okay? And there is a range. I don't care about the range. I care about, it is supposed to be here. If it's here, and it looks like this, still an OH, but it is what? Hydrogen bond. So that is how an OH looks like. The NH is more or less at the same place, but the peak has structure. So it is more narrow, it's around the same region, but it has like little lines on the bottom. Okay? It is not broad, it is closer together. So in general, when you see peaks around the same regions of an alcohol, but they have either structure or they're very sharp. You gotta carry him out.
Attention, an emergency has been reported.
When you see the